Good evening. So tonight, for my first sequence video, we're going to talk about arithmetic sequences. India, I'm giving you enough time to write this, right? Because you're writing it with me. Okay. So what is an arithmetic sequence? Well, there are two ways to define an arithmetic sequence. First, you could think of it this way, that the rate of change between the terms is constant. So the rate of change between terms is constant. So, for example, 3, 5, 7, 9, 11, dot, dot, dot. That means it goes on forever. Okay? So, the rate of change between the terms is just the difference between the terms. And as you can see here, the difference between all of the terms is 2. So this is what we would call an arithmetic sequence. Another way to think about it is that it's linear, because as we know, lines have a constant rate of change, and there's another word for that constant rate of change. You can say it right now. That's right, it's the slope. Okay? So the other way you can define it is if you graphed the value, and we'll call it like a sub n, as a function of n, n being the position in the series, then you'd get a line. Isn't that cool? All right. So I'll show you like that. So up here in this example, you notice that in the first position we have 3. So let's just take a look at this. All right, in the first position you have 3, so 1, 3. In the second position you have 5, so that's like 5. And in the third position you have 7. And in the fourth position you have 9. And in the fifth position you have 11. And voila, that is a line, right? Look at that. Beautiful. All right. So that is what an arithmetic sequence is. Let's do some practice just identifying these things. So which ones of these are arithmetic? Okay, example 1. And you can determine, while I'm writing these out, you can determine which one is. And you can just imagine, like, example 1, check, example 2, check, example 3, X. Okay, so all right, so I'm going to give you one more. And you're going to tell me which ones are arithmetic. Okay, so you've had a chance to think about this. You can pause the video or whatever. This one is not, because the rate of change is not constant. We have 3, then we have 5, then we have 7, right, etc. Okay, so that one's not it. This one goes down, this one goes like up 3, up 3, up 3, up 3. So this one is. This one goes down 3, down 3, down 3, down 3. So this one is, and this one here goes, this doesn't even look like they're differences. They're definitely, the differences are not alike. So that is not an arithmetic sequence. So now you know what the heck these things look like. So now that we have a couple, okay, so let's take this example here. So how would we write a rule for this, and then how may we use it to make a prediction to determine, you know, what the nth term was, like the 100th term or something like this in the sequence? Well, there are two types of rules that we could use. One is called a recursive rule, and one is called an explicit rule. Let's begin with the explicit rules. So position in this sequence is n. So here, n equals 1, 2, 3, 4, 5, 6. And up here we could put a sub n, and a sub n, let's just move it down there. And these are a sub n. Okay? These are the a sub n terms. All right. So the first thing we want to do is we want to find the difference between each term, or yeah, I guess it's called the constant rate of change, or the difference. And what would you say that is? I'm going to call it D. And it's 3, right? We're going up by 3 every time. These are our y values. Notice our x values are going up by 1 every time. So we're really just finding slope, change in y, over change in x. And if the change in x is always 1, it's just really going to be the change of y, and that is our slope. Okay, so you can think of it as your slope if you like. And if we think about this as a line, then we could just identify the y-intercept as the 0th term. This is our first term when x equals 1. This is our second term when x equals 2. This is our third term when x equals 3. Well, when x equals 0 is when we get our y-intercept. So what exactly is that y-intercept there then? That's right, it's -9. Okay? So if we want to write our explicit rule, we can say a sub n, because that's our y value, as a function of position in series, equals 3 times n, slope, minus 9. And there's our rule. So if we wanted to find the 100th term, we would do this, right? 3 times 100 minus 9 equals 300 minus 9 equals 291. All right, so that's what's going to happen if we keep going and going and going and going and going. Pretty cool, right? So how do you write a recursive rule? Recursive rule is basically a rule that says take the previous term and do something to it to get the next term. So therefore, we have to think about what a sub n minus 1 really means. A sub n minus 1 really means the previous term. So in other words, if I said that n was equal to 6, and I asked you to find a sub n minus 1, that means that you're looking for a sub 5, and a sub 5 is 6. Well, that's kind of confusing because I said n is 6. Let's try another example. Let's say that n equals 4, then a sub n minus 1 means that we're looking for a sub 3, and in this case, a sub 3 is 1, 2, 3, is 0. Okay? So a sub n minus 1 means the previous term. So what are we doing to each previous term here? Well, you're just adding 3. So in this case, our rule would be a sub n minus 1 plus 3 is equal to a sub n. So if we want the 5th term, we find the 4th term, and we add 3. So that you can see it up here. Okay, this is what's called a recursive formula. Now, the one thing I have to do is I have to define how big n is. And if n is 1, then we're asking for the 0th term, which we don't technically have. So n has to be greater than or equal to 2 here. So we're looking for the 2nd term. We need the 1st term in order to find the 2nd term because it's recursive. Okay? So this is what's called a recursive rule. And this right here is what we call an explicit rule. So I'm going to give one practice problem here, and I'm going to ask that my pen writes for me. Okay, so I'm going to do this. Let's see, we'll start with 12, and then we'll go down to 3. These are very symmetric. I didn't mean for that to happen, but whatever. Okay, so here's what I'd like you to do. Find the explicit rule, the implicit rule, and then find a sub 100. So pause the video, do it by yourself, and then see if you get the answer when I come back when you're done, okay? Okay, so take a look at what I did, and I hope you got it right. So we found the slope here. Notice it's -4, not +4, because it's decreasing. To find the y-intercept, we go backwards 1. If this is a sub 1, a sub n will tell us what y equals when n is 0, or a sub 0, and that's 16. Okay, so that is our explicit rule. I said implicit, and I should have said, I apologize, I should have said recursive. That was silly of me. Okay. Recursive rule is we take a sub n minus 1, previous term, plus -4. Or we could be sophisticated and say a sub n minus 1 minus 4. If we want to find a sub 100, or the 100th term, it would be silly to use the recursive rule because we'd have to do each rule. This is why explicit rules are really very helpful. So we just plug 100 in for n, do the math, and out you come with -384. This makes sense because this is decreasing, so obviously we'd think we'd have a pretty big negative number.